You know, it's funny how sometimes science fiction just starts feeling less like fiction.
Oh, absolutely. Things that seemed impossible generations ago are suddenly on the horizon.
Exactly. Like controlling technology with just your thoughts. I mean, it sounds wild, but that's basically the huge goal behind Neuralink, right?
Yeah,
Elon Musk's company.
that's the one. They're really diving headfirst into brain-computer interfaces, or BCIs. It's ambitious stuff.
Totally. So today, for our deep dive, we really want to unpack Neuralink. Look at the incredible potential, but also some of the, let's say, potential challenges too.
Right, the promises and the pitfalls.
Yeah. And we've got some interesting material to draw on transcripts from YouTube channels like Monster Inc., Technality, even one called Peekaboo Kids. So quite a mix,
Varied perspectives then. That should be good.
hopefully. Our mission basically is to sift through all that and figure out what plugging our brains directly into computers really means. So we'll cover, the tech itself, the medical hopes, the maybe crazier non-medical ideas, the ethical sticky points, that whole animal testing story, and where things stand with human trials.
Sounds like a comprehensive look. It's definitely a field where science, engineering, and ethics all collide in a fascinating way.
Definitely. Okay, so maybe let's start with the basics. Before we get too carried away,
Yeah.
what is a brain-computer interface, fundamentally? And what's Neuralink's specific approach?
Okay, so a BCI, brain-computer interface, is essentially trying to build a direct communication pathway right between your brain and some kind of external device, usually a computer.
Like a direct data link.
Exactly. And Neuralink's way of doing this involves actually implanting a small chip in the brain. It's about the size of a coin, apparently sits behind the ear.
Okay, behind the ear. But how does it talk to the brain? It's not just sitting there, is it?
No. The key is these incredibly thin wires, almost like threads that have electrodes on them. These get inserted very precisely into the brain tissue itself.
Wow.
And these electrodes can then detect the electrical signals that neurons use to communicate. They can record this activity and potentially, down the line, maybe even stimulate activity.
Well, it's reading the brain's electrical chatter.
In essence, yes. And that data, those patterns, get sent wirelessly from the implant to computers for analysis. You're essentially like downloading brain activity for research or control.
Right. I remember Musk called it something like a Fitbit for the brain.
He did use that comparison. Yeah, suggesting this kind of continuous monitoring and data flow.
And this isn't just theory anymore, is it? They've actually put one in a person now.
That was the big news, yes. January 2024, Musk announced on social media first human implant, said the person was recovering well.
Did they say anything about results?
Early days, but he mentioned promising neuron spike detection. So the device seems to be picking up brain signals as intended. This is a massive step from animal tests to, actual human application.
Yeah, huge. Okay, let's dig into the science just a little bit more. How does a chip even begin to understand what those electrical signals mean? Like turning a thought into clicking a button.
Well, our brains are just these incredibly complex networks, right?
Yeah.
Billions of neurons firing in patterns. When you think about moving or see something or feel something, specific groups of neurons fire in specific sequences.
Okay.
The Neuralink chip, with all its electrodes, is designed to listen in on those patterns. The challenge, the really big challenge, is mapping those patterns, figuring out, okay, this specific burst of activity reliably happens when the person intends to move their hand like this.
So it's like learning the brain's code for intentions?
Kind of, yeah. Learning to decode it and then translating that decoded intention into a command for an external device, like moving a cursor or controlling a robotic arm.
Which sounds like it could be absolutely life-changing for people with certain conditions, like paralysis comes to mind immediately.
Precisely. That's a major initial focus. For someone, say, with quadriplegia, the connection between the brain's command center and the limbs is broken.
Right, the signal can't get through.
Exactly. So a BCI, like Neuralink, could potentially read the brain's intent to move right from the source and then bypass that damaged pathway altogether.
They can send the signal directly to
a prosthetic or a computer. Both are possibilities. Control a prosthetic limb, operate a computer or smartphone, maybe even regain some control over their own muscles if combined with other technologies like functional electrical stimulation. It's about restoring function and independence.
So these medical uses are really the primary driver, at least initially.
That's certainly the stated goal. They talk a lot about treating neurological conditions. Parkinson's, for example, involves issues with motor control. Epilepsy involves, uncontrolled electrical storms in the brain. And paralysis, as we mentioned.
The idea is to alleviate symptoms, maybe restore functions that were lost.
Yes, improve quality of life in very tangible ways. That's the big promise.
But you hear Musk talk, and the vision seems to go way beyond just fixing medical problems. There's talk of enhancement.
Oh, definitely. The longer-term vision, or maybe the more sci-fi vision, absolutely includes cognitive enhancement. Things like boosting memory, improving focus, maybe even altering how we perceive things.
Altering perception. Wow.
Yeah, and Musk has thrown out some really ambitious ideas, like potentially curing autism or helping blind people see again. Now, those are huge leaps requiring massive advances we haven't made yet.
Sure. Sounds incredibly complex.
Yeah.
But even the simpler stuff, like just thinking a text message instead of typing it.
Even that basic level of thought control over technology would be pretty revolutionary. It opens up accessibility in profound ways for people with disabilities, letting them interact with the world, the digital world, much more easily.
Okay, so the potential upside is huge.
Yeah.
But let's talk about the flip side. One of our sources mentioned dark side. When you have a direct line into the brain, what are the big ethical worries?
Well, the first, and maybe most obvious one, is control. Who controls this incredibly powerful technology? And crucially, who controls the data that's coming directly from someone's brain?
Right, because that's not just data about what websites you visit, it's data about your thoughts.
Potentially, yeah. Or at least the neural correlates of your thoughts and feelings.
Right.
And that raises the specter of misuse. Could governments or corporations use that access?
To do what? Influence people.
That's the fear. Could your decisions be subtly nudged based on your neural responses? Could your memories even be theoretically altered or rewritten? It sounds like dystopian fiction, but when you're talking about direct brain access,
The line gets blurry fast. It makes mind control seem less like fantasy.
it certainly brings those concepts into a more tangible realm, and it forces us to ask really deep questions about mental privacy. In an age where digital surveillance is already everywhere, what does it mean if our actual thoughts aren't truly private anymore?
Yeah, what does privacy mean then? If someone or some algorithm could potentially interpret your emotions, your intentions, maybe even alter them with code.
It fundamentally challenges our ideas of autonomy and free will. How do you ensure your thoughts and actions are genuinely yours when there's a machine interfacing directly with the organ generating them?
Yeah, that's a heavy one.
Yeah.
How do you even begin to safeguard individuality in that scenario?
Exactly. It highlights the absolute need for, really robust ethical guidelines, strong regulations, maybe even new societal norms about how this tech can and can't be used. Preserving that core sense of self has to be paramount.
Okay, moving from the hypothetical future to the past. There's also been quite a bit of controversy around Neuralink's animal testing, hasn't there?
Yes, that's been a significant point of public discussion and criticism. It really came into focus around 2020.
Was that the pig, Gertrude?
That's right, Gertrude the pig. They showed they could track her brain activity related to her leg movements on a treadmill, but the bigger controversy involved experiments on macaque monkeys.
Monkeys, okay.
These were done between about 2017 and 2020 in partnership with UC Davis, the University of California campus.
And wasn't there that video of a monkey playing Pong with its mind? Pager, was it?
Yes, Pager the monkey. That video got a lot of attention, showing the monkey controlling the game paddle just by thinking. It was a striking demonstration of the technology's potential.
Looked impressive, but there were problems.
Well, an advocacy group, the Physicians Committee for Responsible Medicine, or PCRM, raised serious allegations. They got hold of hundreds of pages of documents from UC Davis
Great.
and filed a complaint with the U.S. Department of Agriculture. They alleged that the monkeys experienced, quote, extreme suffering due to inadequate care and highly invasive experiments.
Extreme suffering. That sounds really bad. What kind of things did they claim?
Their complaint detailed issues like infections from the implants, complications from surgeries, and psychological distress. PCRM claimed that out of 23 monkeys used, at least 15 had died or were euthanized by 2020.
15. Wow. How did Neuralink and UC Davis respond to that?
They acknowledged that 8 animals were euthanized during that period, but they maintained that these decisions were made for humane reasons, like managing other health issues or unavoidable surgical complications. They strongly denied allegations of animal cruelty and stated everything was done according to regulations and ethical protocols.
Wow. Very different stories there.
Very different interpretations of the records, yes. It's worth noting that after 2020, Neuralink built its own in-house animal research facility, its own vivarium, and ended the collaboration with UC Davis.
Trying to get more control, maybe? Address the concerns.
That could certainly be part of the motivation. But regardless, the whole episode keeps the ethical debate about animal testing, especially for this kind of invasive brain technology, very much alive. Is the potential benefit worth the cost to the animals?
Right. A tough question. So, shifting back to humans, where are we now? Musk is known for, let's say, optimistic timelines.
He is indeed. He talked about human trials starting way back in 2020, which obviously didn't happen. More recently, he's been suggesting implants in humans within the next year, but timelines have shifted before.
And crucially, they don't have full FDA approval for widespread human trials yet, do they?
Not widespread approval, no. That January 2024 implant seems to be part of an initial feasibility study, likely under very strict oversight. Getting broader FDA clearance for larger trials is still a major hurdle they need to clear.
And they're not alone in this race, are they? I think I read about another company already doing human trials.
That's correct. A company called Synchron, they have a different approach, less invasive perhaps, using blood vessels to place their device near the brain's motor cortex. And they have started human trials.
So Neuralink gets the headlines, but Synchron is actually ahead in terms of human testing right now.
In terms of having FDA approval for ongoing human trials, yes. It shows this isn't just a one-company race. The whole field is moving.
Which underscores that until we get more data from Neuralink's own human subjects, we don't really know how well their specific approach works in people or what the practical problems might be.
Exactly. There are lots of unknowns. What happens if the chip malfunctions? What are the long-term risks of having this hardware embedded in your brain? Infection is always a risk with surgery, especially brain surgery.
And then there's the security thing we touched on. What if someone could hack into your brain chip? That sounds terrifying.
It's probably one of the scariest potential downsides, isn't it? If someone could remotely access or interfere with a device directly linked to your neural activity, the potential impact on behavior, health, decision-making, it's deeply unsettling to contemplate.
Yeah, really is. Still, Musk keeps talking about these incredibly futuristic ideas, right?
Yeah.
Downloading memories, summoning your car telepathically.
He definitely paints a picture of a very integrated future between humans and AI via these interfaces. Downloading thoughts, uploading skills. Very sci-fi.
But how realistic is that, near term? What do other experts think?
Well, there's a fair amount of skepticism among neuroscientists about how quickly those kinds of advanced applications could become reality. The brain is just so incredibly complex. Even reading motor intent is hard. Manipulating memory or consciousness is orders of magnitude harder.
Right.
And some point out that even the monkey experiments, while impressive engineering, haven't necessarily shown fundamentally new neuroscience breakthroughs compared to decades of academic research in BCIs.
So it comes back to that core question again, doesn't it? Are the risks, the costs, ethical, animal welfare, potential human dangers worth it for an outcome that might be amazing, but is still largely unknown or maybe even unreachable in the ways Musk envisions?
It's a central dilemma, really. Balancing that incredible potential to help people, especially those with severe disabilities, against all these very real and very serious risks and ethical considerations. It's a tightrope walk.
Okay, so let's try and wrap this up. It feels like Neuralink is this incredibly ambitious project. Huge potential benefits, particularly for medicine, treating tough neurological conditions.
Absolutely. The promise there is undeniable.
At the same time, it throws up these massive red flags, these big ethical questions about control, privacy, what happens when we can directly manipulate the brain. Plus the whole animal testing debate and the simple fact that we just don't know the long-term effects on humans yet.
Precisely. It really hammers home how important it is to have strong ethical guidelines and careful oversight as this technology develops. We need safeguards.
We really do. The potential is just too transformative, for better or worse.
Agreed. We need to proceed with caution and a lot of public discussion.
Definitely. And maybe here's a final thought for everyone listening. Thinking about all this, the tech, the hopes, the fears, what does that future actually feel like? A future where our minds are directly plugged into machines. What does it really do to our sense of being human, our autonomy, even how society works?
That's a profound question.
It is. Something to keep chewing on, I think, as the story continues to unfold.